Alright, welcome back everybody. In this video we're going to look at the last example from the Introduction to Related Rates problem. And example 3 looks like this. The base of a pyramid-shaped tank is a square with sides of length 8 feet, and the vertex of the pyramid is 7 feet above the base. The tank is filled to a depth of 2 feet, and water is flowing into the tank at the rate of 2 cubic feet per minute. Find the rate of change of the depth of water in the tank. And we've got a little hint here with the volume formula for a pyramid, which will come in handy for us later. Alright, so first things first, we've got a pyramid-shaped tank. You guys know I'm not the greatest artist in the world. But my pyramid looks roughly like that. And we're told that the tank has a base that has squares with sides of 8 feet. I'm going to label those on a diagram because the tank doesn't change, so those values are going to remain constant throughout. And that the vertex is 7 feet above the base. So that measurement there is 7 feet. Alright. We're told that the tank is filled with water to depth 2 feet. But I'm just going to draw in some generic water here. And we will call the depth of the water, what should we call that? Let's call it H. Doesn't really matter what we call it. Alright. And now I'm going to write down all the information I have in terms of the variables that I know. We're going to be looking when H is equal to 2 feet. We have that the water is flowing into the tank at a rate of 2 cubic feet per minute. That's the change in volume. So dV dt is going to be 2 cubic feet per minute. And we are looking for the rate of change of the depth of water in the tank. So we're looking for dH dt. Okay. Now, if you look at the water that's in the tank, you'll notice that it's not a regular shape. It's not a pyramid. It's this pyramid with another pyramid cut out of it. And so what we're really looking for is we're going to take this pyramid right here that I'm highlighting in the fuchsia color. And if we take that volume away from the volume of the entire tank, that's going to give us the volume of the water. And so let's try and set up an expression for that. So the volume of the water is equal to the volume of the tank, which is 1/3 times the base area of the tank times the height of the tank, which is 7 feet. So that's the volume of the tank. And we're going to take away from that 1/3, and if I call this dimension S, and then this dimension right here from the top of the water to the top of the tank is 7 minus H. So then the volume of the air in the tank is 1/3 S squared times the quantity 7 minus H. Now, since we know H and we know dV dt, and we're looking for dH dt, we want this formula to be a formula strictly in terms of V and H. And so we want to replace S with what it's equal to in terms of H. And the fact that the pyramid is similar to itself will enable us to do that. Excuse me. And I'm just going to set up a little similarity relationship here. Draw it off to the side. Maybe change colors. S, the side length of the smaller pyramid, is to 8. The side length of the big pyramid as 7 minus h is to 7. And now solving, because of this similarity relationship, I want to solve this for s. So I'm going to multiply both sides by 8. So s is equal to 8/7 times the quantity 7 minus h. And now I can substitute that into my volume formula to get the volume strictly in terms of h. So I've got 1/3 times 64 times 7. Let's see, that's 448 over 3 minus 1/3 times 8/7, quantity 7 minus h, quantity squared, times 7 minus h. And if I simplify that, I'm going to have that the volume is equal to 448 over 3 minus, let's see, 8 squared is 64, 7 squared is 49 times 3, that's 147. And there's an expression for the volume. And now I'm going to go ahead and differentiate this with respect to time. So dv dt is equal to, derivative of 448 over 3 is 0. And so I've got negative 64 over 147 times 3 times the quantity 7 minus h, quantity squared, times the derivative of the inside, which is negative dh dt. And I want to solve this for dh dt so that I can substitute and simplify. And let's see, that's going to give me these two negative signs cancel each other out. So I'm going to get dh dt is equal to, and I've got 147 that I'm multiplying both sides by, over 192, 64 times 3, times the quantity 7 minus h, quantity squared. And now in order to find the value of dh dt, I'm just going to substitute in my known values. Got 147 times 2 over 192 times 7 minus 2, the quantity squared. I'm going to go ahead and calculate this. We've got 147 times 2 over 192 times 5 squared, which is 25. And I get 0.06125. And now all I need is my units. And let's see, change in height. Height is measured in feet. With respect to time, time is measured in minutes. So the units for this is going to be feet per minute. Alright, that's the end of example 3 from this lesson, the end of this lesson. See you guys next time. Hope you have a great rest of your day.